Hello everybody, I'm Nick, and in this video I'm going to introduce you to the concept of pub/sub messaging or publisher subscriber messaging and explain why it's effectively at some capacity a must for any microservice architecture or serverless architecture, but also most modern monoliths. It's actually the easiest way and the most effective way to decouple applications. Now this video is sponsored by AWS, which means I will be using AWS specific technologies to showcase the concept. However, if you want to use Azure or GCP or roll your own with something like RabbitMQ, the concept is the same and the code is basically the same. What changes is the client and the APIs a bit. But fundamentally, what you're going to learn here, you can adapt to other technologies. Now, since the video is sponsored by AWS, you can get the source code for this video for free from the description down below. And you can also use the text I have in the description and on your screen right now to get a free $50 credit on AWS to try things out. However, everything you're going to see in this video for the first 1,000,000 requests is completely free. And even after that, it is incredibly cheap. So you don't have to worry about that. If you like that type of content and you want to see more, make sure you subscribe, ring the notification bell. And for more training, check out nickjapsas.com. Now, before I move into any code, let's first understand fully what the concept we're diving into is. And for that, I'm going to bring the whiteboard. So let's start from the basics. So let's say we have two services. We have service A here, and then we have service B here. And every time little Nick over here interacts with this service, which might be like an API, then that service A might need to tell something to service B, because, for example, when Nick adds an item in his basket in an e-commerce website, then this service B over here might be related to metrics collection to see the behaviors of Nick and might want to do something with it, or maybe it wants to remove the item from the stock just so no one else can actually get that while Nick has it in his basket for, let's say, 30 minutes. This is very common. But then what happens is on that same action, service C might also be interested in that. So what happens? Well, what you might think happens is service A now will also have to call service B. But this is all synchronous communication. So the request takes whatever in here, let's say it takes 10 milliseconds, and then this communication takes another 10 milliseconds, and then this communication takes another 10 milliseconds. If we're lucky, this is very low latency, and then you can also have an amount of services that might be interested in that interaction. And clearly that doesn't scale well. And also, it doesn't need to be synchronous communication. It doesn't need to happen at the moment that Nick says, hey, add over here my item into the basket. It could technically happen asynchronously. Another problem is that if we also had service D here, service D might only be interested in 2 to 3 of the total, let's say, 10 actions that Nick can have with service A. So we would like to filter those actions, but this service over here shouldn't know that this service over here is interested only in a subset of the actions. Wouldn't it be nice if service A could say, hey, customer created, or item added in basket, or I don't know, item removed from basket. And then these services can choose to opt in to listen to that action and do something about it. Well, this is exactly what we're going to be implementing. So let's draw that. So what we want to have is service A over here, and then let's also have service B, C, and D. And in the middle, we're going to have what is called a topic. And this topic will be related to what we want it to be related. This could be customer actions, this can be basket actions, this can be anything actions that we want to define this to be, but it will be specialized. And every time Nick interacts with service A, then service A will publish a message in this topic. So A now is a publisher. And what B, C, and D, those services can do is subscribe to the topic. And now these are subscribers, like you all, hopefully. So stupid. And this is basically pub/sub in a nutshell. It's this idea that you have this topic in the middle, and then you separate who puts data in that topic, the publisher, and who can listen and consume that data, the subscriber. Now, what's great about this architecture is that you're still getting all the benefits of having a resilient queue that has a dead letter queue if things go wrong, that things could be moved into. You can have replayability of messages when you consume. It is very robust. And the publisher only needs to make one action. It doesn't have to make sure that it atomically does a bunch of actions for a bunch of other services that can process the request asynchronously. On top of that, let's say that service D over here is only interested in created requests. So customer created, or I don't know, basket added in item, just a subset of the requests. The topic over here can have a filter to that subscription and can say, do you know what, D? I'm only gonna send you those created messages. All the others you don't care, I'm going to just dump them. Everyone else will still get them, but that service D, since it doesn't want it, it won't have to process them, which is absolutely fantastic. And basically that's it. Now in the Azure world, you would have this in a single service, the Azure Service Bus, and that Azure Service Bus has the functionality to deal with topics and subscribers in that resource. AWS is a bit more flexible because you can actually have different types of consumers. It doesn't have to be a message bus, it can be other things. We're gonna see that, but this also means that because the main consumer in our case here will be a queue, which is the SQS service in AWS, we can actually reuse all the code we wrote in the previous video where I show you how you can use queues in your system and use all that here, and then mainly focus on the publisher and on the AWS side to show you how you can wire up things. So if you want to get caught up with everything queued and message bus related, I'm going to put the video in the description and in the card top right corner of your screen to check that before you go forward, because you need to have the context of a queue and a message bus before I show you the publishing, the filtering, and the subscribing. All right, so let me show you where the starting point of this project is. So I have the solution here that you can find in the description, and it has three main components: the consumer, which is what we had from the SQS video, then the contracts, which is the messages we're going to be consuming, so customer created, customer deleted, and then customer updated over here. And then I have a publisher, which currently has nothing. It is just a console application used to demonstrate publishing messages into the topic. Now in AWS, I'm going to be interacting with two services, that is SNS and SQS. SQS we talked about, it is the queuing and message bus technology that AWS offers. It's actually one of the first services they launched. And then SNS, which is the notification service, which will be used for the topic that pushes to the queue. First, I want to go ahead and create two queues. So I'm going to select SQS over here and say create queue, and I'm going to use a standard queue. I don't care about first in, first out delivery. And the reason for that is because standard queues that don't guarantee first in, first out or FIFO scale better, because since the message ordering is not preserved, you can actually consume faster because you have less guarantees. Now you might be thinking, well, what if I want first in, first out delivery to make sure that my messages don't get scrambled around and I don't process the past in the future? Well, there's actually a solution to that problem we use in the microservice world, and if you want to see a video on that, leave a comment down below. But for now, we're going to go with the standard queue, and I'm just going to say customers here. So this is a queue that processes customer data, and I'm not going to change anything here. I'm just going to create it as it is. We will be going back here to change something, but not yet. And I'm going to go to queues again and create a second queue, and I'm going to call that customers filtered. And this is where I'm going to showcase the filtered side of the processing, where we will only consume a subset of all the messages that go into that topic. And now with that, I can go to SNS, or Simple Notification Service, and I can create my topic. So my topic will be customer actions. And I'm going to go next step. I don't want FIFO here either. FIFO actually tells you about the up to 300 publishes per second, which might be super high for most scenarios, but in the systems I've worked in the past, this would not cut it, not even by a long shot. So we had to go with a workaround to solve the concurrency issues that this might cause. But standard is absolutely fine. I don't want to change the display name. I don't want to change anything here. I'm just going to create it as it is. And now I have my topic. So what I want to do is be able to publish in this topic. And to do that, I'm going to go to my project and I'm going to start writing some C#. So this is my starting point. And what I want to do to get started is search for Simple Notification Service in AWS and create that. And I'm going to create a little utility class to wrap my publishing logic in. So I'm going to say SNS publisher. Again, SNS is where we're going to be publishing in the topic, and that will need to have a private read-only Simple Notification Service, or Amazon Simple Notification Service. I'm just going to call it SNS for short, and then we're going to inject it from the constructor, and I'm going to say public async task publish async, and I'm going to say T message here, a generic type. And this method will have two parameters. First, I'm going to have the topic ARN or Amazon resource name. And then I'm also going to have the T message, which is the message I want to publish into the topic. And I'm going to add the constraint as well. I'm going to say where T message is iMessage, because I have an interface that I use for all of my contracts over here. So you have to inherit from that interface to create a contract. And then the implementation of this is very simple. You need a new publish request, because remember, we're publishing something into the topic, and we need to specify two things here. First, it is the topic ARN, where the thing is actually going. So we have that from the parameter over here, and then the message as a string, which will be a JSON serializer.serialize message, and that's it. Then if you remember from the SQS video, it was also a good idea to put the message type name in the message attributes, which you can think about as headers or metadata for the message. So to do that, all I need to say is request.messageattributes.add. By default, they're empty, and then name of iMessage.message type. And then I need to create a new message attribute, which is how message attributes are defined. So the data type, in this case, it is a string, and the string value is message.message type name. And then all I need to do to send that is say await sns.publishAsync request. And that's it. Of course, this has a response. So you could, if you want, deal with the response, for example, sequence number, message ID, content length, the status code to see if it was successfully published. You can deal with all that. For our demo, we're just going to assume that it was published successfully. And now that I have that, I'm going to create the client. So new Amazon Simple Notification Service client. Now, many of you watching this video see that I don't provide any credentials for AWS services. This is because my machine has been authenticated. It is very unlikely in AWS that you're going to have credentials. It is actually way more secure by default, because in AWS, you actually authorize the services themselves, and you say that this service can make these actions to this other service. You're going to see all that actually in this video too, because we will be allowing SNS to do something with SQS. So West 2, London, here we go. And then create the publisher. So a new SNS publisher goes here. We pass down the client, and that's it. And now if I want to have the customer created event and create a new customer, so customer created, ID 1, full name, Nick Chapsas, and then that's it. And then all I need to say to publish that is await publisher.publishAsync. First, I need the topic ARN. I can get that from the cloud, and I can actually generate that as well, because as you can see here, the structure of it is very predictable. This is the same for all SNS. This is the region, this is the account number, and this is the topic name. So this is basically what we need here. So I can just put it here. Normally you would have it in a config, but I'm just inlining it to make everything more visible. And then the message is the customer created object. And that's it. So now technically I could run this. And if I go ahead and I run this, this will work fine. In one throw, it will work absolutely fine. In fact, I can just quickly get the response from here. So response, just to show you that it will actually do something. So I'm going to go ahead and debug it. As you can see, we have that request, and I step over this, and then we have the response, and the response is an okay. The thing has been successfully created. We have a content length, and everyone is happy. However, since I don't have any subscribers to that topic, this message won't go anywhere. It will just be deleted, which is where we're going to go ahead and add some subscribers. So I'm going to say create subscription to that topic, and I'm going to choose a protocol. Now that's very interesting, because SNS allows you to have different types of consumers here. For example, you can publish from SNS to a Lambda if you want to. It doesn't have to be a queue. You can send an email. You can make an HTTP request with the message body as the post request body. You can even send an SMS. You can push into Kinesis Data Firehose for some stream analytics. And I'm pretty sure you could even send a push notification on a phone or a desktop computer, but I can't see the option here now. But what we're going to be choosing is SQS for this example. And I'm going to go with the customers, and I'm going to enable raw message delivery. Normally, if you don't enable this, the message itself, the body we are sending, will be wrapped into some metadata related to SNS itself. But in this case, we don't care about it. If you do care about it, you can add it. And we're going to leave everything as it is. I'm going to create the subscription. And now that I have the subscription, I have my consumer service here, which is able to handle that. By handling it, it will just write something in the console. Now, even though I added my subscriber and the code is ready, I can't quite actually get this to consume the message yet. So if I go here, run the service, which is configured to listen to that queue, and then I run the publisher, you will see that nothing actually ends up here. Nothing is showing. And the reason for that is because AWS is secure by default, and we need to actually allow SNS to publish into SQS by modifying its IAM policy. So I'm going to stop that and go back into the console. And what I need to do now is go to SQS. I'm going to choose customers here, and I'm going to say access policy. And I'm just going to modify this statement to allow SQS to publish in here. Now, I have the policy created already because I've done this a million times before, but you can even use the policy generator to generate that automatically. But I'm just going to paste it. And what this basically means is that any AWS principal is allowed to make the action SQS message send, which is the action that sends the message inside SQS. And then the resource is the customer queue, the SQS queue. And then the condition that needs to be met for this to be true is that if the ARN equals the source ARN, which is the SNS ARN, then this can actually work. And basically that's it. We go in the bottom and we save. And I'm also going to do that for the filter queue, which we're going to be using in a second. So let me just quickly add that over here. I'm going to add filtered over here and then filtered over here. And that's it. Now I can go ahead and also wire up the second subscription because yes, now we have a one-to-one relationship, but the whole point here is that that topic can now have multiple subscribers. So I'm going to create a second subscription for the filtered one. And in the beginning, it won't have any filter, but we're going to go back and actually change this filter policy to make it very, very interesting. And I'm going to create that and make sure actually that it has raw message delivery enabled, and that's it. And now we have that created. I'm going to go ahead and run both services. So both the consumer that consumes everything and the filtered one, which currently has no filter. And I'm going to run the publisher and show you that both the main one and also the second one both consumed this message. This is how easy you can implement basic PubSub with AWS. Now, here's the interesting thing. By default, this filter one doesn't have a filtered. However, AWS supports very flexible filtering when it comes down to subscribers. You might be wondering, well, why would a service be interested only in a subset of messages? But think about it. You might have a microservice whose its responsibility is that, in our case, if a customer spends more than an amount of money, because you can see that this customer updated object has a decimal which represents the lifetime spent amount of money for a given customer, you might want to email that customer when they exceed an amount of money to give them a discount code or upgrade them to a VIP member of the system. You wouldn't do that all synchronously as part of the payment process. You would have a service listening for that. And if it detects that, hey, you spent more than an amount of money, then it deals with that in some way, maybe upgrading its user status in the system, emailing the user, creating a discount code or a celebration email. There's tons of things you can do with this. And this is where filtering comes in. In our case, we're going to create a filter that is only interested in customer updated events to begin with, and then we're going to extend it even further to only be pushed to the subscriber if the lifetime spent is more than a specific amount of money. So first, to begin, I'm going to change this customer created to customer updated. So this will be customer updated, and then I'm just going to give it some lifetime spent. So let's say that they spent this amount of money, and then I will be publishing this into the topic, and I'm going to go back into the console, and I'm going to choose my topic, find my subscriptions, and choose the filtered one. And in here, I'm going to say edit the subscription filter. Now, the subscription filter has some great documentation explaining everything you need to know about how filters work. Now, I know how they work, so I can just show you how we can filter against that specific thing. And filters run against message attributes. So if you remember, we're pushing that message type name as a message attribute. And actually what I'm going to do is I've made a little extension which processes the message and then puts its values in the message attributes so we can filter against them. And I'm just going to add it real quick over here and say for each request message dot to message attribute dictionary, and call that attribute request dot message attribute dot add attribute dot key and then attribute dot value. And that's it. And now I can go back here and I can say that I want a filter on the message type name, and I want that to match anything in this array. And this array for now will only have one thing, customer updated. And let's leave it like that for now. So what I'm saying here is only notify the subscription if the message type value on the message attribute is that thing, customer updated. And then with the filter in place, I'm going to run both services, both the filtered and the unfiltered one. And I'm going to run the publisher as well. That for now will only send the customer created. This is only accepted by the unfiltered, not the filtered version. Remember, we have the filter over here that says only send me messages where they have a message type name named message attribute whose value is one of these things in the array. For now, it is only the string customer updated. And if I go back here and I show you the unfiltered, then yes, we are getting it. And if I show you the filtered, there is nothing here. This never got notified. But if I change this to a customer updated again, and I uncomment this and I rerun the publisher, then both of these services will get it. Here you go, the updated on the unfiltered and the updated on the filtered, which only consumes customer updated. Now, like I said before, this can be even more flexible. So while this is running, I'm going to go here and select edit, and I'm going to change the filter to also say where the lifetime spent value, and I'm going to add some rules here as well and say numeric because it is a number, and the filter is if it's greater or equals to that value, then push that message to the subscriber. If it doesn't match this condition, then don't. And we're gonna update that real quick. It's gonna take a second to propagate, and now with the filter changes propagated, I'm gonna go ahead and run the two services again, the unfiltered and the filtered. I'm going to send that request that only has 50 as lifetime spend and should be below the threshold that the filter subscription has. So I'm going to run it now. And as you can see, the first one is getting it. The second one is not, because it is below that threshold, even though it is of type customer updated. But if I increase it to a value above that, and I run the publisher again, then as you can see, the first one still gets it, and now also the second one gets it because it satisfies the condition of being of type customer updated, and also the numeric value of that property should be more than that value. And that's it. You should now have all the fundamentals to get started with PubSub in .NET using AWS in this scenario. And all this knowledge is actually transferable. The concept of filters exists in other services. The concept of PubSub is obviously the main idea that everything else is built around. And you can choose to go down your own path. But this is the approach I've been using for the past 3.5 years in very high scale and high throughput scenarios, and has never failed me. If you want to see more in-depth videos on SQS and messaging in general and microservices, please leave a comment down below. Well, that's all I had for you for this video. Thank you very much for watching. Special thanks to my Patreons for making videos possible. If you want to support me as well, you're going to find the link in the description down below. Leave a like if you like this video, subscribe for more content like this, and ring the bell as well. And I'll see you in the next video. Keep coding.